Welcome to session 18. And today we have Thomas Graabaek, who's the owner of Form Factor. And this is another thing. I struggle with this pronunciation over and over again, but it's also the owner of the Graphisoft Center in Denmark. And a couple of months ago, they released their own add-in that they were working with an architect in Denmark for, because of the requirements of life cycle analysis costing, or life cycle analysis overall. And they built this add-on called Design LCA. And kind of going back to the challenges that we're facing at the moment with regards to our role as architects and designers, we need to be focused on how sustainable our designs are and making sure that we design buildings that are as sustainable as they possibly can be. So I really look forward to sharing this session with you and having Thomas go through how this tool works, because it's actually freely available to download. So it's one of those things where once you get to see how it all works in this session today, then you can go away and then start kind of using it potentially on your projects and see how it all goes. So take us away, Thomas.
Hi, my name is Thomas Graabaek. I'm the owner of Graphisoft Center Denmark, the local distributor of Graphisoft products in Denmark, and the developer of Design LCA. We're a small team in Copenhagen, and in regards of Design LCA, the most important person is my colleague Sissel, who has been the mastermind behind Design LCA, and who is only working part-time here while she's finishing her bachelor at the Technical University of Copenhagen. We have a busy schedule today, so we are going to talk a little bit about our collaboration with Linear Architects, a little bit about LCA calculations in general, something about how to do LCA calculations in Archicad with Design LCA, how to make your own EPD data or enter it into Design LCA, and then a little bit about EcoDesigner Star, which is the energy evaluation tool inside Archicad. And afterwards, there will be a live Q&A if you have any questions. Linear is a Danish architecture company who is very focused on sustainability and upcycling of materials. Before we started working with them, they were not using Archicad, but they were looking for an LCA tool that could be used by architects in the early design phases, so they could design new buildings with sustainability in mind and with a strong focus on LCA. And at that time, they were using engineering companies to do the LCA calculations for them. And that meant it was a little bit cumbersome process in the early phases. So the first project we did with them was a competition project in Berlin, Germany, where they were retrofitting an old parking structure to be a modern office building. A lot of the project was about LCA calculations, trying to make the most sustainable building possible. And that meant taking some of the slabs from the parking structure out and reusing them in a wooden structure in a new part of the building. And then also reusing a lot of materials from a nearby mall that was also being retrofitted at the time. And they won the competition mainly due to the sustainability focus and the LCA calculations. These are just some images from the Archicad model that was used for the LCA calculations. The second project we did with Linear was a new building with a lot of upcycled materials, and it's a small project done with wooden modules, and then with a facade cladding of cut out wall pieces with bricks, cut out concrete walls with graffiti on, some roof tiling that was reused, and a lot of other materials that was found nearby. And this is actually an early sketch project. But if you really want to work with LCA and try to push the LCA as low as possible with as few CO2 emissions as possible, you need to look at every part of the building. And therefore, we had a very detailed project, even though it was early design phases. This image is from the wooden structure that was modeled in Archicad. So the more you model, the more precise the model is, the more precise the LCA calculation will also be. And the takeaway from this, from our point of view, is that Design LCA and LCA calculations in Archicad are possible from the early design phases, but also through the detailed phases with a very complex model. And in the end, Linear found out that Design LCA was the right tool for them to do the LCA calculations on early phase projects, and they started using Archicad at the same time. So a little bit about LCA in general. So the problem is that for the last century in Europe, we have had a huge gain in fossil fuels, and the material import has multiplied many times, and that has generated a lot of garbage. Most of it ends up at landfills. And this problem must be taken care of. So we have to lower the amount of fossil fuels, and we have to lower the amount of materials that are imported and used in Europe. If you look in Denmark specifically, 30% of the CO2 emissions are from the AEC industry. 1/3 of that is from materials used, and 2/3 are from the energy used for operations. So that's heating, cooling, ventilations, and electricity. And it's very dangerous if you look at only materials or only operations one at a time. So there's a direct link between the two. So if you try to lower the amount of materials used in a project, you'll probably have a higher CO2 footprint from operations. And on the other hand, if you try to lower the CO2 from operations, you'll probably have a higher footprint from materials. And that's exactly what an LCA calculation does. It looks at both these parameters at the same time and over a long time period. In Denmark, we have some understanding from existing buildings, and the University of Aalborg, Build University, has made a report trying to figure out where the CO2 comes from on 60 existing buildings. And you can see these columns. The green part of the column represents the CO2 from materials, and the orange part is from operations. And my takeaway from these graphics are that it's very difficult to set a certain percentage of CO2 from operations. On some projects, you have almost zero energy and CO2 from operations, but then you probably have a high CO2 footprint from materials. And on other projects with a lower CO2 footprint from materials, you have a lot of CO2 from operations. And this makes it very difficult just to try to guess where your LCA will end. And that means you have to calculate. And you have to calculate both CO2 from materials and from operations. The second problem is that you have to do this in the early design phases. The biggest impact on decisions are from the early design phases. And if you only do an LCA in the end of the project, you might figure out that it's too high. Your CO2 footprint is too high. And then you have to redo the sketch process to figure out a new way of designing your building so you have a lower CO2 footprint. So the takeaway is that you have to be able, as an architect, to do the LCA calculations yourself. It's going to be very expensive if you have to hire an engineer in the early design phases to do a new LCA calculation for every iteration of your design. So you have to be able to do it yourself. You have to be easy and quick. And you have to be able to do this from the sketching project. An LCA calculation can be many different things, and it can be very difficult and complex. And it's a little bit determined by how many impact categories that you include. So some of the impact categories could be acidification of the sea, or it could be landfill. But in the European demands for LCA, it's only early phase LCA with global warming potential that is considered. So the only thing we look at is the CO2 emissions from the project. And every time I say CO2, what I mean is CO2 equivalents. So even though there are different greenhouse gases that pollute, we transform the different values into CO2 equivalents. So we only have one number to take into account. So we don't have to look at each greenhouse gas by itself. We just convert them to CO2 equivalents. In Denmark, we have had new demands from January 1st, 2023. Every new building must have an LCA calculation. If it's a small building, less than 1,000 square meters, it doesn't matter what the result of the LCA is. And if you have a building that's more than 1,000 square meters, you have to have an LCA that is less than 12 kilograms of CO2 per square meter per year. And this number, 12, that's going to be gradually lowered year by year. So in 2029, we'll end up at 7.5 kilograms of CO2 per square meter per year. And in Denmark, we have chosen to calculate over 50 years. So that's also an important factor in the LCA calculation. To understand a little bit about the different phases that are included in an LCA, I have some Danish slides, so I hope you have strong Danish language skills. The first phases are about taking the materials from the ground or from trees or wherever, then moving them to the factory, and then the emissions from the manufacturing. So those three phases are called A1, A2, and A3. The next phases are the transport from the factory to the building site, and then the emissions from the building site. And they're called A4 and A5. In my slides, they're red because in Denmark, we don't have to include phase A4 and A5 in the LCA for the mandatory LCA calculations. And that's also the fact for the use of the building. The only two phases that we have to include for building use is replacements, phase B4. And that means if you have materials or building elements that will not last for 50 years, then you have to multiply the CO2 with the number of replacements. So imagine you have a window that will only be 25 years old, then you have to double the amount of CO2 from that window because you have to replace it during the 50-year time span. The other phase we have to include for use is the energy from operations. So that means energy for heating, cooling, ventilation, and electricity. And all the CO2 emissions from that is included in the LCA. The next phase is end of life, and we have to include the demolition of the building. And the last phase, the D phase, is for reuse and recycling and upcycling of materials. And then you have completed the whole life cycle. We have translated these different phases into English. And you can see here all the different phases of the LCA. The orange part is the ones we can do in Archicad with Design LCA. And the ones we cannot do is not mandatory in the Danish LCA requirements. And some of them can be very difficult to calculate in general. So let me introduce Design LCA. this is the plugin we have made for Archicad to do LCA calculations directly in the BIM project. We've done the plugin in collaboration with Linear Architects, and what it does is it calculates the global warming potential from the early phases of a project and all the way through the detailed parts of the project too. The entire LCA can be done in Archicad with Design LCA. So you don't have to use other applications and you don't have to involve an engineer necessarily. And it calculates both the CO2 from materials and the CO2 from operations. And I've written on the slide, no other tool does this. So we haven't found a tool where you, without jumping to another application, without entering information from other applications, can calculate a complete LCA calculation with both material CO2 and operational CO2. And the reason that we can do this is because we have EcoDesigner Star inside Archicad. As a small print, there's a little bit of details about this CO2 calculation in Archicad. We use the geometry of the BIM project. So if you don't model it, it will not be calculated. So you have to model everything you want to include in the LCA calculation. Only visible objects are included. So if you turn off layers, that will not be included in the LCA. So GGL objects are generally not included in the LCA. So kitchen cabinets, chairs, and stuff like that will not be part of the LCA. So let's take a short demo of how this tool works. I'm using the Danish template, so it might look a little bit different than your Archicad. And Design LCA will also look a little bit different because in the Danish template, we have added materials with EPD data, so you don't have to enter that manually. And we also made composites with these materials, so it's really fast to add building elements with real materials and the consistent LCA data on them. But you'll be able to do a template like this. Some countries are also already working to provide Archicad templates with LCA data. So it's still a real world example. So I'm just modeling from scratch a building, so there's no cheating. And it's important to figure out what kind of detail level that makes sense for doing the LCA calculation. Right now, I have massive walls made of nothing, so I changed them with a composite, so now I have real materials on walls, slabs, and roofs. And I want to have a fairly precise LCA calculations, so I do a little bit of enhancements of the model. I also put a foundation on, and the reason is if you optimize the materials for your project for the LCA, the foundation will often be a larger part of the LCA since it's made of concrete. I also do a little bit of modeling outside the building, mainly to show later that I don't want to include that. So this is the entrance on the site geometry, on the terrain. And now I have a building exterior that I'm confident with. So I want to add something inside the building, and that's for two reasons. One of them is that I have to place rooms, zones later on. So I need to have some internal walls that can divide these zones. But also because if I know that I'm going to have rooms and walls, I might as well include them so I have a more precise LCA calculation. Right here, I'm adding a staircase, and the reason for that is that it will be a little bit more CO2 after I add the stairs, but there's also going to be less CO2 from the slab after I cut the hole for the staircase. So again, it's going to be a more precise LCA. So I'm going to adjust this staircase a little bit, and I'm going to cut the walls with the roof. So the model seems to be fine. Then I add zones. First, I'll add some doors, and now I'm ready to add my zones. And it doesn't matter what function the different zones have. I'm going to choose that later in EcoDesigner Star. So I just have to add zones, but I need to make sure that they touch all the external walls and slabs and roofs. So therefore, I use solid element operations to cut the zones with the roof. And then I do a section just to look at my building. I think this is a good sweet spot for how detailed a good model should be to do a fairly precise LCA calculations. So now I'm ready to look at my CO2 emissions. So after installing the Design LCA plugin, I have this small menu, so I can go to the Design LCA menu and look at the Design LCA palette. I have the CO2 from different parts of the project, and they're shown right away. I also have the settings panel where I can set the years, the lifespan of the project, the 50 years that we're looking upon, and also the phases that I want to include. I can look at the material browser where I have EPD data with the CO2 footprint from the different phases of each material and also the surface life. And one of the clever things about Design LCA is that I can enter this EPD data by square meters, by cubic meters, or by kilograms in the same way as the EPD has the units, with the same units as the EPD. So now I move to EcoDesigner Star, and I want to do my energy evaluation. So the first thing I do is I make a thermal block, and I add all my zones to this thermal block. And I assign an operational profile to the thermal block, and I also assign some building systems. We're going to look at those in a second. So looking at the operational profile, I set it to apartments, but there's a lot of preset operational profiles, and they have a lot of data included. So make sure these data fit your project. The next thing is where the project is located. In our template, it's located in Copenhagen. But if you have another location, then you can just enter the longitude and latitude and download the correct climate data for that area. You can also set wind protection or horizontal shading if you haven't modeled a building or forest or whatever is next to your project. And as you can see, the way you operate this energy evaluation tool is very intuitive and easy. Now I look at the different building systems. So that's the heating, the cooling, the ventilation, and there's a lot of settings. So make sure they're set correctly. And also the energy source factors that determines how much CO2 emission there will be from each energy source. So now I update my zones, because then it will automatically detect all the exterior walls, roofs, and slabs. And I can see the different composites here, and it will automatically calculate the U value for each element. It's a little bit more difficult with doors and windows. Here you have to go to a catalog and determine how many layers of glass, what kind of gas is between them, and also what kind of material is used for the framing. But it's not something that will take a long time, and it's fairly easy to understand the process. So now I've assigned materials for the doors and windows, and I can also add some solar shading if I need to, and that's it. Now I'm ready to do the energy evaluation report. So I click the button, and it will in seconds make a report for me so I can evaluate the project. But I don't need that. Actually, I only need to use the send to Design LCA functionality. And now I have the operational CO2 added to my LCA calculation, and also the square meters of the building. Now you can see I can change materials. I can go from one composite to another. And every time I press the update button inside Design LCA, it will make a new LCA calculation with the new materials. I'll just try to change the roof, see what that changes in my LCA. It goes a little bit the wrong way, so I'll probably change it back to have a lower LCA calculation. And you can see on the graphics that the blue column is my project, and the reference values I've entered in Design LCA will be all the gray columns. And in the Danish template, I made a schedule where I can choose the material for windows, for the materials here too, and also for doors. And that is changed a little bit differently in the international version, where you have to go to the settings of the object. So now I'm getting close to the 12 kilograms of CO2 that are Danish requirements. So I'll try to look at each material grouped by the layer they're on, and to see which are the lowest hanging fruits when I need to optimize the material use of my building. First of all, I saw this concrete slab outside my building. I don't want to have that included. So let's just choose it, go to the settings, and exclude it from the LCA calculation. Done. Then I'm going to look at the materials once more to find out which layer has most CO2 and which material on that layer has most CO2. And that's the gypsum used on the walls. So it's easy with a test project like this. I'll just delete one layer of gypsum and see how that affects my LCA. And now I'm under the 12 kilograms of CO2 per square meter per year. If I do changes in geometry, if I change the angle of the roof pitch, if I change the size of the windows, if I add windows or doors, my whole LCA calculation will change. And this will, in other applications, take a long time because you have to take all the quantities away again. Look, at this example, I'm going to stretch the side of my house, so I have more square meters, I have more materials for walls and slabs. And all I have to do is update the LCA here, but it's probably going to do something to my energy use also. So I'll just update my energy evaluation. And what you saw before was setting all the settings first. I don't have to do that again. I just have to update my zones and send to Design LCA once again. So it's only a few clicks. And when I open my Design LCA palette, it will automatically have the information from EcoDesigner Star. So, and those changes actually pushed me above the 12 kilograms of CO2 per square meter per year. So that's something I have to work on. Here I can set the amount of replacements for windows, the service life for windows and doors. And I can also change the amount of CO2 I want to put for installations. So this is roughly how Design LCA will work. This was a high-speed video, so I'm going to dive a little bit deeper into all the different settings. Here you can see the export for Excel. If you want to calculate or manipulate the numbers by yourself. In the Danish template, we've also included a few layouts with documentation of the LCA calculation for the building permits. So everything is set up automatically. And if you work a lot with LCA, it might be a good idea for you also to set this up in your template. And that's the entire Design LCA workflow. So diving a little bit deeper into how Design LCA works, what you have to do is you have to download Design LCA. It's a free add-on. It's on the Design LCA website. And you have to read the manual. It's a fairly complex process to do LCA calculations, so please read the manual. There's a lot of small tips and tricks to understand how Design LCA works. You install the plugins to Archicad, and you also have to import the property set and the library into your project or into your template. And then you can start configuring Design LCA and your project. So after installing the plugin, you'll have a menu for Design LCA, and the first thing you probably want to do is to open the settings dialog. Here you can set the considered service life. In Denmark, it's always 50 years. And you can see that with the small blue tick marks, Design LCA wants to have an automatic data entry from EcoDesigner Star. So if the blue tick marks are there, you have to use EcoDesigner Star to add the data. The first one, the gross floor area, that's the area that is used for dividing this operational CO2 per square meter. The operational CO2 is the next line, and the third one is perhaps a Danish thing. It's called the reference floor area, and that's the square meters that is used to divide the material CO2. So gross floor area is for dividing the operational CO2, and the reference area is for dividing the material CO2. If you take away the tick marks, you can enter those values by yourself, perhaps from other application or from schedules or whatever. The next part of the settings pane is which phases you want to include. In Denmark, we don't include very many of these, but in some countries, all will probably be included. Then for the graph, the columns on the graph, you can choose if it should be the total CO2 of the project, if it should be the CO2 per square meter, or as in the Danish standards, the CO2 per square meter per year that is shown. And then you can enter your own reference values, perhaps from local standards or requirements, or just whatever your building owner prefers. Then you have to enter CO2 emissions on each material. And you get this from the Environmental Product Declaration, which is shortened as EPD. So a lot of product manufacturers, they make an EPD for each of their products or each material they have, where they set or where they describe how much CO2 is in each LCA phase. And all you have to do is go to the Design LCA building material settings, find the different materials in the building material list, and then enter the data from the EPD. And here's an example for a Danish EPD. It's for bricks, and it's a PDF you download, and there's a lot of pages, and you only have to look at a few of those pages. The first one is the unit. So the unit is not kilograms, but ton. We have to divide by 1,000. And then we have to enter the density of the material into the building materials under the physical properties. Then we have to go phase by phase and enter the EPD data for the global warming potential, GWP. And often it's put in this special E notation. And if you cannot calculate that, you can just copy and paste it into Excel, and it will show you as a normal decimal number. Then we have the energy evaluation with EcoDesigner Star, and that's for the phase of B6. And it's actually pretty easy to understand what it does, but it's also a complex tool. So what you want to do is you want to do a thermal block and add all your zones to this thermal block. Then you can say this thermal block have an operational profile. It can be apartments, it can be a shop, it can be an office functionality. And after that, you add the building systems for heating, ventilation, cooling, and so on. And that's a lot of preset data inside the operational profiles, and you have to check out these match your local standards. Then you have to set the location of the project. It's done by latitude and longitude, and you can find that on Google Maps. You just place a pin and you can read the latitude and longitude, and it will automatically download the weather data used for the energy evaluation. If there's shading from some other part that's not modeled, you can add that manually, and the same with wind protection. If there's a forest next to your project, so there's not that much wind, you can say there's wind protection from the north, for example. Then you have the building systems. Please check up on each building system you add, that the settings for it is according to your local standards, and also check the energy source factors. And the energy source factors are how much CO2 there's from each kilowatt hour of each energy source. So you can go district heating, how much does that pollute? Electricity, how much does that pollute? And in Denmark, we have special numbers, giving generic numbers from the state that we just enter here. Be careful with the electricity mix in the bottom part of this. You can, if you don't have the CO2 emissions from electricity, you can put an energy mix together with some wind energy, some solar energy, some gas and coal energy. But if you do that, it will not use the value you have entered for electricity above. So it's one or the other, and you cannot do both. Then you can look at the structures inside EcoDesigner Star, and due to the different composites, Archicad will automatically calculate the U value. And if you don't like it, you can just unlock this small padlock and enter the value that you have from the producer of a prefab element, for example. The same with windows and doors. You choose the different windows and doors, open the catalog inside Archicad, choose how many layers of glass, which kind of gas is between them, and what kind of framing material is used. You can add solar shading if you want to, but you can also unlock the different numbers and then enter the values directly from the window or door manufacturer of your choice. Then it will generate this report, the energy report, and this is a design tool, and it's really valuable. So if you look at this project energy balance, you can see the energy that is put into the building month by month and the energy that goes away from the building month by month. And what you want to do is you want to have as much solar gain in the winter as possible, and probably as little as possible in the summertime to avoid overheating of the rooms. And every time you do a new iteration of your product, every time you change something in the model, you can do a new energy report and see if it's moving your project in the right direction. So it's going to be a really good energy optimized building. For DesignLCA, this report is not necessary. All we need to do is use the command export to DesignLCA, and it will transfer the CO2 from operations and the square meters of the rooms directly to DesignLCA. Even though that you have already set the materials and the layers of glass for energy evaluation, we have to do that for the material CO2 as well. And that's done with expressions inside Archicad. And you have to load the Design LCA property set for it to work. So when you have this property set imported, then on all different building elements, you'll be able to see a small part of the properties where you can set a percentage of CO2 you want to add. So I only want to have 25% of the CO2 on this wall, or you can choose to include it or exclude it from the project. And the way you do this is by, in the include line, you can choose true or false. The same on windows and doors. On doors, it's a little bit more complex because here you can choose between 7 different door types, and you'll get the CO2 from the materials afterwards. The same with windows. With windows, you have to determine the material from the framing and also the amount of layers of glass. And then you're ready to do the LCA calculation. Everything is done directly in Archicad, and you can see the result in different ways, how the composition of the CO2 is spread across the different materials. And you can place these diagrams directly on the drawings. So this is a Design LCA main palette. And what it shows you is the global warming potential, so all the CO2 from the building. So that's the total number of CO2. It also shows you the CO2 per square meter, and it also shows you the CO2 per square meter per year. So in the Danish case, we divide by 50 year to understand how much CO2 there is per square meter per year. Then there's a pie chart showing you where the CO2 is located. The blue part is from operations. The orange part is from materials. The yellow is materials for doors and windows. And the green one is just 10% that we put off for installations, like piping and ventilation channels. Then we have these reference numbers. So we can see the blue column is my project, and then it will be relative to other numbers or values that I have entered manually. And with doors and windows, I have the possibility to change the service life. So if they will not last more than 25 years, this is the way to tell Design LCA. And you can also set a buffer for CO2 for inventory, for installations, and for the construction process. In Denmark, we only have to include the installations, and generally we just put off 10% for installations, but I could also just put a specific number per square meter per year. A clever thing about this is it's possible to place this calculation on floor plans, on layouts. And if I do this, I have some settings to adjust how I want the graphics to show up. And especially I have the possibility to do a date and time stamp on the calculation. And that's most valuable if you turn off the update from add-on functionality. So if I put the date stamp on, I turn off the update from add-on, then this will be a static calculation, and I can put a new stamp for a later LCA, so I can see the iterations from each LCA calculation. If I want to, I can export this to Excel to manipulate the numbers afterwards. And then I can also, as a design tool, try to figure out where are my most problematic materials located in the project. So if I go to this material report, I will see each material grouped by the layer they're placed on. So I can very easily, with the columns on the right, see which layer have the biggest CO2 footprint, and then find the material under that layer This report is in Danish, so I can see that layer A27 is my roof construction, and I can see the material with the largest CO2 footprint is my insulation. So perhaps I should try to change the material for insulation in my roof to have a lower LCA. Again, I can place this on drawings, and I can have a date stamp on it, and I can turn off the update from the add-on. If I want to import models from other applications, it could be SketchUp, Rhino, Revit, I can import an IFC, and I can still use Design LCA to do an LCA calculation for that project. The secret is that you have to have a fairly simple project. So you don't want to do this with something that's very complex or very detailed. And one reason is you don't want to have too much material information from the model, from other applications, because you have to put new materials and new composites on the project after import. So the best thing is if all walls and slabs and roofs are one material, from inside to outside, with no composite information. And then I just change the materials one by one, and I do the LCA calculations as I would do on something modeled directly in Archicad. Again, make sure to read the manual. We have put a lot of effort into the manual, so there's a little bit of information about LCAs in general, and a lot of information of how to adjust the different parts of Archicad and Design LCA and EcoDesigner Star to have a precise LCA calculation. And there's a lot of places you can go wrong if you don't have the knowledge about it, so please read the manuals. So just to sum up, Design LCA is a free plugin for Archicad 26. It only works with build 4019 or later, and that's because that's where you get the free EcoDesigner Star if you are on a service agreement or Graphics Forward. It works on Mac and Windows, and you can choose what phases you want to include, how long lifespan you want to include, and you can put in your own reference values. It's easy to enter EPD data, no matter what unit. You can find the EPD data and what different phases you want to include. There's service life on all materials, and it will calculate the CO2 from operations using EcoDesigner Star. There's Excel export, and you can import IFC models from other programs. So what you want to do is go to DesignLCA.com, and you can read a little bit more. You can check out the manual before you download. Otherwise, you can download the package, and what you get is a manual, a plugin for Mac and Windows, a library with the stamps, and then a property set to include the material from windows and doors. And that's it. I hope you have enjoyed the presentation. I hope you can see the value in LCA calculation and you want to try this by yourself. Feel free to join me in a second for a live Q&A if you have any questions. Thank you.